Okay, hello and welcome everyone to the WiNoDa Knowledge Lab. My name is Cora. I'm the project coordinator of WiNoDa. WiNoDa is the knowledge laboratory for natural science collections and object-related data. And we're here today for our third session on our webinar series on data science. And today we will have the first hands-on session on machine learning. There's still 3 more webinars coming on this series. So if you are interested, please be reminded that you need to register for each webinar separately. I will put you the link in the chat later on. The webinar is taking place every second Tuesday from 12 to 1. And it is in English. If you missed or do miss one of our webinars, we do record them and put them on our YouTube channel later on, so you can re-watch them if you need to. And I will also send you the link to our YouTube channel in the chat. One more information for you. You can now register for our very first workshop, which is called Decoding Berlin, and it will take place in Berlin at the Museum für Naturkunde on the 27th of November. And you will have the chance to work on our collection data and get exclusive access to behind the scenes of the museum. So feel free to register, and you also have, I will also send you more information on our webpage in the chat. Okay, and then I want to introduce to you our lecturer, Tim Conrad, who will also teach you this webinar on machine learning today. And yeah, Tim, I hope you're ready. Welcome.
I am. Yo, welcome to today's session. Before I start, I'll send you also a link to the chat, which should open, if everything goes well, the link to the PDF that will be the lecture slides of today. I'm doing that because there are some links in these PDFs that you might or might not want to use later on. So if you want to follow along, I will also send these links always to the chat. So you don't need now to download the PDF and go through the links yourself. Whenever possible or necessary, I send the links to the chat. But if you also for later reference want to go through it and don't want to type all these lengthy links, feel free to just use the PDFs. Okay. Then let me fire up my slides. I will try it a little different today to share the full screen, not only the window, because we'll need various windows later. So I hope, windows actually, yeah. So I hope this will all work out. If there are some glitches with the display, just let me know. But should work all right. At least last time I tried, it actually worked. Good. So third session. Last week was school holidays. That's why we didn't have it actually as planned last week. And that's why also next week will already be the next session. So this time we are not in the usual 2-week rhythm, but then we will go back to that. No worries about it. Today will be about hands-on. The main idea is that we have, or I will first give you, since you might have missed, or it's already 3 weeks ago, the last session, a super brief introduction again to machine learning, or a reminder, hopefully more. And then we will have 3 examples, 3 hands-on examples that really should get you started with this Colab or Google Colab, what's it, the web page that we can use to actually start programming in Python. I think in the announcement to today's webinar, there was already the hint that it might be beneficial to have a Google account and even be able to open up the Colab web page. If not, don't worry about it. You can just sit back and relax and follow me while I'm doing that. However, if you're interested, you can also follow the links, and I again send it to the chats, and then you can do the same thing I'm doing here and get some kind of feeling in the best case scenario how this all works. And then the third part, or the fourth example in this order, is actually some actual machine learning task that we will be doing together. Same thing. Not sure how far we will go with the timing. Last times wasn't my timing the best. So let's see how it goes today. However, even if we don't manage to go there slowly and step by step, with the material you get today, you will be able to do yourself. And then you can say you did your first, well, maybe not your first, but you did today some actual own coding with Python and to solve a, well, in this case, classical machine learning task. So summary, you can either now lean back and relax, or you actually follow me through on your own computer and your own collab sessions with your own Google account, and try to see how it works for you, or later on you go through the recording and do it again at your own pace. Good. So this was what we also had last week, one of the hundreds or probably even thousands definitions of what machine learning is. And I put it here again, first of all, to remind you again what we did the last session, and second, to set the stage to what we will do in the next couple of slides, or within the next hour, that is. And the main idea is that, well, machine learning is something that is doing something algorithmic. So there is some cooking recipe, if you want, of steps that do something. That's what an algorithm at the end is. And we use it usually in machine learning stories to parse data. That means to load some data from somewhere. Could be an URL, could be a document, could be PDF, could be some table. We will actually do this in the second or third example. Then we want to learn something from this data. That's what we actually do with the last example today. And then based on what we have learned or can analyze, then we hopefully are able to do some prediction about something in the world. So this is really what machine learning is, given this particular definition here. There are other ones, slightly different ones, but at the end, they all have more or less the same idea. Okay. And then also last time, I gave you the, again, rough comparison about what traditional programming is and what machine learning is these days. That doesn't mean that these days only machine learning is up to date, and that's what people do. Of course, traditional programming is still equally important, if not even more important, because machine learning is really about, mainly at least, analyzing a data or getting an idea about what some data set could describe. And traditional programming, sure, often is much easier to access because you're programming things that you know already about the world. Last time we went through this example of conversion from Celsius to Fahrenheit. You might remember that. The idea is you have some kind of input, then there's kind of a function in the middle. This could be some black box, or, well, white box is more or less the opposite, so you know what's happening there. And then out comes some result. So you put in here, for example, some Celsius, and then output of this machine here, or of this algorithm, is the same degree in Fahrenheit. Good. And then also what we usually know is we know these scales here between, so we can calculate or convert between Fahrenheit, Celsius, and Kelvin, and probably whatever else is out there. And the idea is, okay, how do you approach this with a normal, traditional, that is, kind of approach? And the idea is that you know how to convert it because you got it from Wikipedia, or it's well known, or you have some physics books and you can read it from there. So you know what we call a model, how to go from the input in Celsius and compute then the output in Fahrenheit. Then we can do it in some programming language, in this case Java, can be anything else, can be Python, can be C, whatever you like, and we get our results. And we follow more or less the actual conversion as it's defined. That's traditional. And then the inductive or machine learning or data-driven approach is that you collect some data. In this case, you have, for example, these two thermometers here, and you put them at the same spot, say outside or even inside. And then every 10 minutes or once a day or so, you collect data. You look at the one of the Celsius scale, look at the Fahrenheit scale, and you just put a dot where these two scales are assigned to. And then you have this kind of data here, and you see, well, the higher Celsius gets, the higher also Fahrenheit gets. So you think, oh, this could be some kind of linear connection in between. But since you want to do it with a machine learning or this inductive data-driven approach, you now use this concept of machine learning to learn something about the collected data and to learn a model that is called. And the model, as we also discussed last time, is this red line here. That is our model. Meaning, if we take away the blue dots here, then we would go, okay, what is 10 degrees Celsius? We would go up until we hit the red line. Then we go left and we say, oh, cool, it's around 50, maybe 52 or so Fahrenheit. And that's what our model now shows us. And if you then print what this model in this case means, you go to this equation here, and this is what has been learned from the data. You will find 1.8 times Celsius degrees plus 32. The actual model is exactly that. Problem machine learning is that there's some error connected to that. So you have more or less the right model in many cases, but there might be some slight uncertainties or some slight noises that you have in your model. So it might not be 100% exact, but in many scenarios these days with machine learning, you can actually quite close to the right solution. Good. So that's machine learning. We have some data. We learn some model, in this case, a red line. And then we have something we can work with. And later on, we'll do some predictions as in what if we get 60 degrees Celsius and 1 Fahrenheit, and we can predict what it will be in this particular case. Okay, so this was again just a super short reminder of what machine learning in its essence at least is. And now we go to the next part and try to actually put this, what we just saw, step by step in practice. First example will be what I guess programmers also, or however you want to call them these days, do whenever they learn something new. They have something called the Hello World program. And Hello World just means that you put some programming code and it spits out Hello World to you. That's really what it does. And that's exactly what we will do now. I hope you can still see the full screen. I have now, here, able to move it. So the idea is that we go to this link that I provided here. Again, I will put it to the chat as well. Where's my chat? Here's my chat. And if you go to that link, then you will end up here in something that looks like this. In my case, there is now a couple of already made, that's called notebooks, so programs if you want. What we want is we click on new notebook, or in my case, because it's in German, neues notebook, and then you should see something like the following. Ta-da! We have a blink cursor, so it's waiting for our input. And what we see here now is, well, one line of a notebook, so one tiny part of it. And what we want to do is we want to add a new line, because maybe in the first thing we want to just put a comment. Comments are started always with this hash here. And then you can say this is a comment. And then we click on plus code. This is this thing here. We get a new line directly underneath. And now we put our first command, which is print hello world. And this is now the Python equivalent to putting something on the screen, if you will. So we now execute this. We put on this little play button here, click on it. And if everything goes well after a couple of seconds, because now it just initializes the underlying programming environment, it actually spits out this, what we told it to do, hello world, and it shows hello world here. Now we can change it and can say hello world with an exclamation mark, and again, execute it, and you see that it has been switched to what we just put there. So this is, for some of you, maybe some of you already experienced with that, now a Python program run on this, in this particular case, compute infrastructure that is provided by Google. If you have this Google account, it's for free. You can use as many of these notebooks as you want. Probably not literally. At some point, they will probably put a limit there. And you can use their computing resources. The only downside is that if you have really heavy computations, then at some point in time, they will tell you to pay for it. But if you use it in a normal way, so doing analysis every now and then, or even daily, a couple of times, you can just use this service for free. Good. So that was this very first example where we just opened this browser setting, created this what's called a notebook here. In a notebook, more or less in traditional sense, as you're writing something on it. And what is new now, maybe added through this environment, is that you can actually execute code. In this particular case, Python code. Okay. Second example. Now I want to do something a little bit more complicated or complex, maybe. And if you want to get into this whole programming game, then there is countless, it's probably not the right word, but super many websites also on the internet where you can have a look of what's all happening there and how the code works. Sometimes the equation, sometimes not. I put you now one example here. That is this one. So open the site, which is just a Python page or Python related page. It has also some other programming languages where they give every now and then some introductions to some new concepts or even beginners tutorials and so on and so forth. There are many other ones, but this is one that I like. And what we will do now is that we will use one of the provided examples here, namely this one. That's not too important what it really does. It prints a Fibonacci sequence. Some of you might remember that from some math class I took, probably actually in school. So Fibonacci sequence is a sequence of numbers in which a given number is a result of adding the two numbers that come before it. So you will see first ones are 0 and 1, and then there's the 1 again, and then 1 and 1 is 2, and so on and so forth. So always the two before you add up. And then, and that's now the nice thing, so that first some explanation. It'll also give you the code, how to code this in Python. So we copy this code, just copy paste. We go back to our notebook here. We create another line in which we can put code. We paste that code into this line. And now we see what happens. We will not go through the code now. You can do that in piece if you want. The point is it does something. It does something Python specific. And the point at the end is, as we saw before, it prints something. And then it says, okay, I have a length 7 here. Length 7 means just how long this Fibonacci should be. So 1, 2, 3, 4, 5, 6, and then with a 0, it's a 7. So it's just a parameter that I can do. So we click on play, and it outputs these numbers or these Fibonacci series of length 7 in this case. We can also say only length 4. We run it again, and it's shorter. So that's what the Python code does. Again, today is not a real programming introduction. I'm here to give you the basics and to help you help yourself at the end. Because what happens now is actually super cool and only be possible since a couple of months even. So let's assume we don't really know Python yet, and it's also not really clear what's really happening there, but we want to understand. And for that, Google and also others provide their AI assistants. So in this case, we have Gemini. And so it's their AI assistant. And Gemini is also, when you have a Google account, for free, again, up to a particular number of prompts a day. I think about 1,000 you have a day that you can use. And in this prompt, you can now query or ask questions about the code you just provided. So if you now put in here, explain the Python code as if I am a beginner in programming, and hit enter, then it says, all right, let's break down the Python code step by step for a beginner. And it goes through it and says, overall, what's happening, step 1, step 2, step 3, and it gives you examples and so on and so forth. So this is something that you should embrace these days. Because of course you can also take the code, put it to your favorite other AI assistant if you want, and it will do the same thing. However, having this also now really side by side in your code, and you can also ask about some of these cells or just really any details that you see here, you can really ask and work with this AI assistant until you have more or less the idea, okay, now I understood it. But this is really the gist of the example number 2. No matter how complex the code is, you can always ask these assistants that they're providing with these days and ask it as many questions, no matter how easy or difficult they are. And these assistants will, in most cases, give you actually pretty good answers. And even, again, if you don't really understand why there's a def here or what this print means, and then there's this weird end here, you can really ask everything. You can really tell it to, yeah, well, I will not do this now, but put a prompt, what does the end equals la 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 mean in the line, print, and so forth, and it will really give you and guide you through the answer. And in many cases, it also gives you some hints, like where you can else find information about, so you can really start learning to program super interactively. Of course, you can always take also other larger classes or courses or video tutorials or so, but this is really, if you're interested in, okay, I have some code, I don't really know what it means, I would like to try to understand it, I would like to change the parameters just until it does what I need to do with this code. This is a really, really nice example of how AI can be used these days. Okay, so that was Colab. We'll collab with the Google Gemini Assistant. Once again, there are other products out there that you can use as well. I'm just using Google because in most cases, people know Google and are okay with it and have a Google account. But don't get me wrong, there are other very good assistants and program environments out there that work equally well. Okay, so now we saw what you can do if there's some code that is more or less complex and you can get an idea of what's happening. Next example, and this is, I guess, one of the main messages when you enter the programming game that has changed to, say, 25 years ago. 25 years ago, basically everything you did, you have to write yourself from scratch. That's why I started with this Fibonacci example. So if you wanted to give out the Fibonacci series, you had, or sequence, you had to program this whole algorithm yourself. Today, you use something that is called libraries. Libraries are, roughly speaking, coding blocks that someone collected. So what you can do, instead of writing this whole code here, is, let's do another notebook. We can use some library. And again, in this particular library that we'll be using now, someone has already programmed this Fibonacci sequence code. So we will use a library, or we will install one first because we want to use it. This is done with this pip install. And then I tell the Google system to install library for me. I want to use Fibonacci. Let's see where that works. Now it goes to the internet and tries to find this library, this Fibonacci. And again, in this library, there's many code blocks now implemented already, but if I wanted to, could also look at. And the point is that somewhere it will be also written on how this thing can be used. And what we will use from it is to exactly use that method that will print us out our sequence of Fibonacci numbers. So we make another line here. We say, okay, I want to import, so I want to use a particular code block from this library. Fibonacci, from Fibonacci, I want to import this Fibonacci code block. It tells you as a little tick here that it worked. And now I know how this function is called because I looked it up before. I tell it to, yeah, it gives me already code completion because AI system knows what I want. So I can now just say, print this Fibonacci sequence here of 7. And what I get, 1, 2, 3, 4, 5, 6, because the numbering is different. So I want to have the same as before. I need to put an 8 here. And then I get this number. So without coding anything, just knowing how the method is called and what it does for me, I now have the Fibonacci sequence for which I formerly had to write this whole code myself, and then I get the same result. Well, here I will probably to put a 7, put it again, and then I get this number from 0 to 8. Same thing here, 0 to 8. So here I had to code everything myself. Here I'm using library function. And the main important thing is that there are thousands of libraries that do tasks for you. There is, let's just say, whatever, top 10 library from this website here, doesn't matter too much. There is libraries for data analysis and manipulation. There's libraries for data visualization. There's libraries for, again, visualization, deep learning, web crawling, you name it. There's really libraries for more or less everything you want. And that'll be also then in our last example, the step where we will use libraries to get machine learning code that we can just use in our data. So these days, at least if you're more on the applied side of things, you very rarely really program machine learning algorithms, you use them. And you use them, or you use those algorithms that someone else implemented in these libraries. And of course, one question is, well, how do you know they're correct? Well, you can't. The only thing is that you rely that someone else did all the tests and that the community, wherever that is at the end, tested all these functions and methods and algorithms and said, okay, they seem to work, they seem to do what they're supposed to do. So today, you really use libraries. You need to be able to read your data in a format that these libraries understand, manipulate it if needed, so maybe remove noise or change some names or so. And then you throw, again, another algorithm or a library function on it, machine learning in this case, and then you can interpret the results or deal with the results or learn other models or whatever you wish. So the main point is there's libraries for a lot of stuff, and these days you use these libraries. So that's not that you really need to program quite a lot under the hood. Okay, if you're interested, again, there's numerous sites. If you just type into your favorite search engine, top Python libraries or so, you get lists, and then you can also have a look at how they really look like and what they all do. Good. So next example. Idea is you want to load some data from a file, and you want also to visualize your data. So you want to have a look at of how it looks like. But again, as in the library idea before, you don't want to write now all necessary low-level code, opening a file, putting pixels in your visualization, change colors or so. So again, we will not write all this low-level code, but we will also use libraries. The example I prepared already for you, I'll put it to the chat. So if you click on that link, then a notebook will open for you that I prepared already. And that contains all the code, so we don't have to type it all the time. If it opens in your browser, you probably cannot do too much, but you can say file or Datei in German, and then save a copy. So copy in Drive or so. And then you have it on your own Google system and can play with it and change it and do whatever you want with it. And the idea now is that we go through this notebook step by step. Again, we could also ask Gemini again and say, explain the code, and then it will do that. However, well, I will take care now to explain the main functions at least. But again, be reminded that everything I'm saying now, you could also get in a similar form from Gemini. And you can also get then even more explanations if you're unclear about something like, hey, what does really this plotting mean, and so on and so forth. So always remember, there is these AI assistant these days. And again, at least in programming tasks, they're really good and really rarely make mistakes. Okay, good. Now, we have code that, again, we want to use as an example to load some data from some file and visualize it in some way. And visualization will be covered, I think, in 2 weeks or in 2 sessions from now. There's a lot of stuff that you can do with visualization. We will just use it in a super simple way just to understand, okay, there are some data somewhere and we want to see how it looks like. Good. Now, the first thing we do is we want to look at the data that we actually are working with here. So we put that to the URL, and we see this is the data that we are dealing with. It is, in this case, some stock market, doesn't matter too much. The point is there's some date, there's some open course or open amount, some highs, some lows, and some closing. So that's the data that we're actually looking at and working with. Again, not too important for the example that we are looking at. It's just some data. It is tabular. That's the idea. Good. So what we do in the first part, again, we're importing the libraries we're needing. In this case, we need 2 libraries. The first library is what is a Pandas library. It also showed up in the slide here. Pandas is one of the most important libraries in Python, and it's good for data analysis and manipulation. Okay. So we can use it. And what we can do with this Pandas library, that's this PD here for Pandas, we can say, dear Pandas, read a CSV file, so a comma separated list, in this case, from this given URL here that I just showed you. So there's somewhere on the internet, there's some table in a CSV format, and I'm telling this pandas library, just please open it for me and save it in a variable that I can use later on in my code. So it reads it, transfers it to my program, and I've now saved in this variable called my data frame, and I can do stuff with it. Good. So let's first execute this. So my libraries will be important. The second one we will talk in a minute about, that's this plotting library that we will use. It was also in this slide here. That was this Matplotlib. We will use that later. Good. So my libraries have been imported. I will load now my data from this URL I showed you. Then I'll do something that is also a Pandas feature. I can just show the head, so the first couple of lines from the data I just read by calling this method here again, comes also from the library function. Click on that, and it shows me the numbers that I showed you also before. Let's have a look at it. So it started with the date, what is it? October 9th, 23. And then there was something here, 0.65. And as you can see, October 9th, 23, and something with 65 at the end. So it's actually really the data that we saw here in tabular form. So now we've loaded it into our notebook, into our program, and we can deal with it. Okay. Now, this is also just not too interesting, but the problem with that data is that it has a space in front. So there's little spaces here before the open and the high. And sometimes the scripts don't like this. So we are removing that. Again, use Gemini later if you're interested on what's really happening here. What is happening is that this term or this word with the space and then open is replaced in my data with just the open. So the space removed. Same goes for high and low and close. So I just rename the columns. Doesn't really have a big effect, but later on you will see when you will work more with these kind of scripts that it's always easier to have the actual right names of something, because otherwise I would have put here now a space in front of it. No, that would have been correct, but in the other cases I would have put a space here, so a bit confusing. Therefore, we usually clean our data and transform it so that we can really use it. Now we sort our data. Again, the point of this is not that you understand really every line of the code. What is interesting is that using this pandas variable now that comes from the library, I can just tell it, look, sort my table by the column that is called date. So by this column, my data should now be sorted. Why we'll do that is quite clear, because if it's stock market data, then of course we want to have it actually in the correct order. And we are not quite sure whether in the order we got it in, it was really correct. So we sort it just to be on the safe side. So now we still have our data. We corrected the header names or the column names. We sorted it. And now the last thing is that we use now from the Matplotlib library. So we have this PLT here that was as we called the library for the plotting, and we just show, look, here's my data. Please plot the date column versus the close column, and show me the result. And then what you can see is then the result here. Not super pretty, but I guess it serves a purpose. It shows you now what you could, if you have a really fast brain, maybe you see already how the courses look like. If not, you just see it now visualized in this notebook here, and you can get an idea of what's happening. So again, the point of all this is not to really go with you step by step through all the single lines that you can do with Gemini if you're interested in. The point of this is to see, well, in 4 lines or 5 lines maybe, I have done something that is reading data from somewhere, in this case from an URL, but this could be something also on your computer or that you have stored somewhere else on your hard disk drive somewhere. I just inspected the head of the data, so how does it actually look like, confirmed that it's really what I wanted. I did some super simple manipulation of the data. In this case, I renamed just the headers to be in the correct way. I removed these spaces here, just with some quite simple command. Then I sorted something based on the date column, and then at the end, I plotted it. And once again, this is not supposed to be now, okay, this is how actually each commands work. This is really to show you in really a handful of lines, you can read something and display it. And then if you want it now, you can make this line, I don't know, green, you could add labels to it and so on and so forth. And this is also something you might want to try then later on at home to tell Gemini something like this. So you can say, given this code, you put it, how would I add a label for the x-axis? And then it will tell you how it's actually to be done. And then we can just copy this code, put it here, run it again, and now there is state, right? So you can really interactively with these assistants, you can now play with it. How to change the line color to green. So you can do that. And then it tells you, if you want to put it to green, then you can add this color equals to green here. So at the end, just copy the whole code because it's easier. And we will have now a green line. So again, the point is not that you now really understand each of these little details, but the point is to understand, it's actually not that hard to do Python programming if you're using these library functions. So if you're using really the libraries that support what you want to do, and again, the next example will be then about the machine learning part, it is actually quite easy these days to even use Python in a really, really powerful manner. And what I now showed you with is just visualizing a little data set. There's enough tutorials out there that show you, I have data about this and this thing from this domain, and I want to show it in 3D. And then you can show it because the library is for that. Or I want to analyze the main characteristics in this and this fashion, and there will be library for that. There will be a template for that. There will be some tutorial for that. So this is the idea of not necessarily becoming a professional Python programmer, but being able to use the functionality that Python and these libraries bring you. And it's not always super important to understand every little bit and piece. I guess that is also true for other parts of life. I'm not sure whether everybody still understands how a car is really working these days, but we still use it. And similarly, although not the really same thing, you're using today algorithms also from the machine learning domain, which can help you in your life to get what you need in your professional life maybe, without really knowing what is really down to the bits and bolts in that algorithm. Okay. I put you also on the slides some more links to more material where you can also find more about this matplot, for example, and then you can also have a look at it. Good. Right, that was just the explanation of what we just did, which now brings us to our last example. And I first guide you through that. And then, as I said, the idea was that everybody can do it themselves. However, I will do it also slowly in front of you, just so that you see how it works. But the idea then of the last, say, 20 minutes of the class would be that if you have started your collab already, that you already tried yourself how this code really works. So we will turn now to the actual machine learning example of today. We will use linear regression. Linear regression is, sorry, this was switched, is exactly what we did before. So what we had in the motivating example of today and also last week. So we had this point cloud here, or this collection of points, where we thought, okay, that seems to be some linear correlation here between Celsius and Fahrenheit. So let's learn a linear model. And the model, again, as we said earlier, is this red line here. And the actual equation that is underlying this model is this one here. So we have a plus 32 and 1.8 times the Celsius. And then this line comes out. And this is what we are trying to do. So this method that is going from this point cloud here to this red line is called linear regression. Linear, again, because it's a line, and regression because you want to learn how one variable in this case is depending on the other. So how is Fahrenheit depending on Celsius? And we will use, again, a library, in this case, Scikit-learn. Scikit-learn is one of the most important general machine learning packages or libraries in Python. There are many others as well. I like Scikit-learn because it is quite robust. So if they tell you they have implemented another algorithm, it's usually correct how they implemented that. There's many other also research codes out there that claim to work and then they don't at the end. Long story short, Scikit-learn you can usually use out of the box without worrying too much that there's some errors in there. But there's hundreds, if not thousands, also other libraries that implement a lot of other machine learning techniques. So in this case, we have in the Scikit-learn library, we have methods for classification, for clustering, dimensional reduction. These are all the words that we also used last time in the webinar. And what we will use now is regression. So we use some of the regression methods from Scikit-learn to actually do some actual machine learning. And again, the type of machine learning that we do is I have some data given like this one, and I want to learn a model from it at this point. Good. To do so, we will again open another notebook. There is again a notebook I prepared for you. I put it to the chat so you can open it yourself if you want. It is based on another example that you can also read about somewhere else on the internet. So if we open that notebook, and then this happens. So it's loaded for you. This time we are loading another data set, namely this here. Let's open that also in the browser. You see again, it has a similar structure as before. It has a value separated by a comma and another value. This time there's no header information. We will see what that means in a second. So before there was this, you might remember, the header information was state and opening and high and low and so forth. Now we don't have header. We just have the number separated by a comma. And we go through it again as in a similar style as before. You could also play with Gemini now and tell it to explain the code for you. And at the end, what happens is that we first import. Oops. That was one of these things. Now I have too many of these sessions already. So I don't need that anymore. So you can only have, I think, 2 or 3 sessions in parallel unless you pay, but for usual cases, that is not the problem. Good. So now it works. I can load my libraries. I tell it again, I want to have my plotting library, it's PLT here, as I call in this code. I need pandas to read my data. And that's a new thing now. I have my Scikit-learn library that I'm using. I want to have a linear model. And in particular, I want to have the linear regression model that I'm using. It's machine learning approach. Next part, again, will be I read this data I just showed you, or here's the URL for it. I read it using my pandas. So this PD comes from the pandas, which is short for that. And I want to, again, show the header of that. And what happens now is that it didn't realize there was no real header information. So that's why there's one line more where things is actually part of the header, while it's not. But remember, this is just visualization. There's nothing to do with how your data was reloaded. It is just visualized it the wrong way. And you can, of course, fix it if you want. But just for now, because there is no header information in the data, it just displays the first line as a header. But again, it doesn't affect anything that you will do later. It just says it loaded correctly. So first line 32.5, 31.7, let's see, 32.5, 31.7. So that seems to be all correct. Okay, now comes something that is also important and similarly annoying, but it's important to understand that is necessary in some way. So now the data that we have is in this particular form here, but this is not how the machine learning algorithm from this particular library needs it. So what we actually need is that we need the x coordinates. So these are this ones here, the first column basically. We need as one list, and we need the y coordinates in one list. So what we need from this data is a list of 32.5, 53.4, and so on as one list, and another list that is 31.7, 68.7, and so on and so forth. So we need to understand what the library expects the data to be, or which format the data is like, and we loaded it with the pandas function in another format. So this one is a table. And now from the table, we use some pandas function and extract basically column 1 and column 2. Again, why the command is written like that is this point in time not too important. We do it that way. So we tell it, okay, in my x variable, please store only the values from the first column. And in my y coordinate or variable, please give me only the y as the second value in each of the rows. And if you then print it, so we now just print our x, then you will see that we have 53, 61, 47, which is not correctly. Yeah, okay, it's like this. Yeah, 53, 61, 47. So from the table, it just extracted now the first row. Same thing you can do with a y if you want, and see that it's indeed 68, 62, and so on and so forth. So it extracted, it didn't take the header with it, but this can be also changed later. Okay, so now we have our data converted from the table to two lists. One has the first coordinate, one has the second coordinate. And then what I do is I can now just show my data. So I can use again this plotting, in this case a scatter plot, where each dot now represents one of the rows in the table. So for example, 53, 68 should be somewhere. 53, 68 could be maybe this point here or this point, unclear. But so every row now is interpreted in x, y coordinate, and therefore a dot is plotted or painted wherever each row has the x point coordinates. So we just have now the similar visualization before. Remember again our example from slide 3, where we said, okay, we collect our Celsius Fahrenheit data and now want to learn this red line. This is actually different data. I think it's about head sizes and brain weight or so. Doesn't matter too much. It's just some data with x, y coordinates. Okay, now, and this is the machine learning part, this one line. I now tell it, okay, I want to learn a model, a linear regressor. This is this red line here. And please, dear library, use your linear regression function and fit the model to my data from this x and y coordinates that I have extracted from my table. And that is it. And you can see it's almost instant, so it takes a couple of milliseconds to do. And that's it. Now I have learned a model. I have found the red line. Whether or not it's good, we will see in a second. And I can use it now to plot basically my data, which I will do now. So I will again plot my original, my blue data points, and I will plot now my model that I just learned. This is y red here, that is based on the model. And you will see that this line, in this case, I will do green, not the red, fits more or less my data. One can argue, should the line be a little bit more up or a little more down or so. But at the end of the day, this seems to work quite well, as in I have found now a line that is going through my points in the, at least according to this algorithm, in the optimal way, which means that it is optimally positioned such that the distance between every blue point to that line is minimal. So if I would put the line up here, then the distance to all these points would be much larger taken together. So that's why the green line needs to be through this point cloud and positioned in such a way that all the points, if you project them to the line, are minimal. The sum of all these distances is minimal. That's what the definition of the linear regression is actually. Next step is then I can also print the learned equation as we had before. Remember in our Celsius Fahrenheit example, there was now our equation was whatever 1.8 times Celsius plus 32. And in this particular example here, our equation is 1.28 times x plus 9.9. That's the equation of this green line here. And that I can use if I'm only given the x value. With this equation, I can now calculate the y value. Yeah, and before it was given x was my Celsius, and I want to calculate the Fahrenheit. Now I have x and y values, so given x value, I can now calculate the y value. And that's machine learning. in the Pandas or in the Scikit-learn and in the Python world. Once again, there is many other ways and libraries and ways to do it, of course. But in this super simple example, if the task is to your given data, X, Y coordinates, you want to learn a model, in this case, a linear one, this is really the only line that you need. And now you might ask, okay, cool. And how many other algorithms are there? And the answer is, well, dozens, in particular in this Scikit-learn library. You can just replace it by some other name that is included in the library, and you do machine learning using another algorithm. And that's this power of libraries. Once you have the data in the form that this library needs, in this XY column-based form, you can now apply it to whatever else you want. It's a simple example. We can use some nonlinear function to learn, so it's not a line anymore, can now a polynomial in this case, so a parabola or something else. So for this case, we use now the polynomial features from this Scikit-learn library. Rest stays more or less the same. I will not go to details now. And if you run that, then you see that it's now slightly curved. You can go also to higher degrees, 27, and you will see that the curve fits the points more or better. But at some point in time becomes too exact, and then the prediction is not as good anymore. Long story short, just with using these polynomial as in like a nonlinear function now, the rest stays more or less the same because you're using the same library still. You can use different machine learning models or different models that you're learning there, even if it's still about regression, but can be anything else, with literally changing 1 or 2 lines of code. So we can try and play and use it and see how it works with the data and go to more advanced things. We will cover deep learning next and in 2 weeks' time from now. And at the end, you will see that this using of machine learning, using these libraries is quite simple, and getting results is very, very easy. Validating these results and see whether it makes sense also for the question that did at the beginning is a different story. But first of all, creating results and using machine learning in this way, in this Python way with these libraries, is actually really simple. Good. That brings us more or less to the end of today's task. Today's webinar. Again, be reminded of, once you have now your code, you can again use Gemini. You can say, hey, that's what we did earlier. I'm going to create the axis labels in the plot, and then we'll tell you what to do, and then we'll show you also how to do it. You can ask further questions. Okay, cool. And you know what, if the label should be larger or it should be tilted by 20 degrees or so. And these assistants will really tell you how to do this. Once again, applying it is easy. Whether it does make sense for a task at hand, different story. But just using these tools these days is actually very, very easy. Last slide. This is just what I was showing towards the end, or the last example, because that's a key problem in many machine learning tasks. That's what I want to stress it at the end once again. So what we did before, or in the first step, is we fitted a linear model, right? So we said it has to be a line. Please, the machine learning algorithm, fit a line through this. Learn a model that is basically a line. How the line is oriented, you need to find out, but it will be a line. In this example, we said, okay, please fit a polynomial with degree 23. 23, so it could have been also degree 2, so that's x squared, or a third order polynomial, so to the power of 3. And then we can see whatever we put in here, at some point it will break, but the higher you go, that's what I thought, the higher you go, the better, seemingly at least, it fits your data, but it also becomes a bit less reliable in terms of predicting. So with machine learning, you can fit many models to your data, but you always need to understand whether or not this model is actually the right choice. And that's your choice. You choose which model you're taking. So if your data looks like this here on the right-hand side, you can say, okay, I want to fit a straight line to it, or I want to put some model with degree, in this case, 3 through it, so polynomial that we did here, or something even higher, and your data will be fit or fitted, right, according to the algorithm. But whether it's a good fit or not, this is what you as a domain expert need to understand and need to choose a priori, because that's how you run algorithms. You tell it, as an example, hey, that's my data, fit a line through it, or hey, that's my data, fit a polynomial of degree 23 through it. So this is really the crucial part why, as I said earlier, with these libraries and with these Python tools, you can create results, no problem. But where these results are the good ones or the correct ones or actually fit to the task at hand, this is something that you need to decide and why it's important to have the knowledge for it. Good. And with that, I'm actually this time 5 minutes before the end of our hour. So if there are any questions, I'm happy to take them now. If not, I'll once again put you the link to the slides in the chat for those who have joined later, so you can redo everything that we did also at home. Again, all the tools are free. Free as I need an account, but I don't need necessarily to pay for it. If there is really large questions that you want to understand or to get a little bit more into details with, send me an email. Email is always on the first slide of the slide deck. And then I'm also happy to answer them also offline. Yeah, I hope you learned something today and got the rough idea of how all these tools are working. Hope to see you next time again. And again, we open for questions if there are any. This was machine learning. Linear regression is part of machine learning. However, there's machine learning algorithms that have some kind of randomness built in. So you start them 5 times and you get 5 different results. But it's still machine learning. You're optimizing the way the line goes through the point cloud, right? And if you solve it, we call it globally. So if you tried out every single possibility and choose now the best one, then you will always get the same result. If you solve it using a heuristic or only locally, as we call it, then you might not have seen every possible solution, and you choose the one that was best up until you stopped it. Say you have a really big data set, and doing a global, so getting for the best answer result takes you 5 days, but you need it tomorrow. Then you use some kind of heuristic or some local algorithm, still machine learning, still everything as before, but you will get only the best answer within these next 24 hours. Yeah, so this might not be then the best that is actually possible. Maybe it is, you don't know that. So that's maybe what you're referring to. But if you solve a problem globally, then you always get the same result.
Okay, thank you, Tim, very much for the session. Please, yeah, feel free to use the chance for any other questions you might have. Tim is now available for your questions. If not, once you the session is finished, we ask you to give us some feedback, and you'll find an evaluation form. So if there are no other questions, as Tim said, you are very welcome to contact him or contact WiNoDa via our help desk, which you find on our webpage if you have any further questions. Tim, now there is actually a question in the chat.
Yeah, I just saw most data type returned by linear regression fit function. And that is basically, or you can even have a look at it if you want, just very briefly. Everybody who is bored now with the answer can, of course, happily leave. Let me quickly share that screen. That should be this one. So we have this linear regressor here, and that is the model that is learned from it. And the model itself is an object that contains a couple of things. And by things, I mean, for example, the coefficient and the intercept. So what is the slope and where it starts basically, but there's also some other properties that it returns. But at the end, the return itself is an object, and you can use this object then to, for example, predict new values. So in this case, what we did is that we predicted the y values for all the x values that we had. So we used the predict method of this object that was returned, or in this case, we just got back the actual formula that we needed at the end. But the real object that was given back is just the model that you learned, including the details that you learned to use it also for the next part. Good. 1 o'clock.
Thank you all for participating, and thank you again, Tim, for teaching.
You're welcome.
We hope to see you again. Yeah, remember the next webinar is next week already. So hopefully see you again next week. Have a good day. Bye.
Bye-bye.